So let's look at mixture of root. Mixture of root. Alright. Now there are some expressions there are some expression of an integral function having two or more fractional powers. Having two or more fractional powers. Don't forget that what we did in our previous video, that one is when it's involving with only one square root. But with this, you are going to get two or sometimes even more than two. Alright? Very good. So if more than one fractional power is present, it may be possible to eliminate all of them at once. All of them at once. Alright. So the problem here is that we have to eliminate the root. And the task ahead of us is that we have to choose the exponent of u. You have to choose the exponent of u to be the LCM of the denominators of both fractions. Alright. So let's quickly look at our first question and see how we are going to deal with such questions. Alright. Very good. So looking at the question we have here, you can see that this is involving with two fractional powers. Alright. Very good. Let me say this is involving with two roots. You can see that this is the same as 1 over square root of x, 1 plus this is cubic root of x dx. So you can see that this is involved with this and that. And the idea of solving this is not that you are to go and multiply this by this by this. It's not like such. But what we are going to do is very simple. Okay, it's very simple. Very good. Now, what do we do next? Now here it's involving with two roots. I nearly school roots. It's involving with two roots. Alright. One is x raised to the power half. Another one is x raised to the power 1 over 3. Alright. So what we are going to do is that we are going to let x be equal to u. Watch. We are going to let x to be equal to u. But the u that we are going to let x be equal to, you see, yx. Don't forget that in our previous video, if you have square root of ax plus b, you end up by writing u is equal to ax plus b. That is, u is equal to the inside. I'm linking you to the previous video. U is equal to the inside. But you have to write something here, and that is what is here. So if what is here is 2, you write 2 here. If what is here is 3, you write 3 here. I hope you can see that. Very good. Now, in this case, you can see that the inside is x. The inside is x. So we are going to let the inside, which is x, to be equal to the u. But which one are we writing? Are we writing 2 or we are writing 3? Because here we are dealing with two roots. I hope you are getting me. We are dealing with what? Two roots. One is square root, the other is cubic roots. So we can just write 3 and we can just write 2. But we can still do something. I hope you are following. And that is by finding the LCM of of 2 and 3. So when you find the LCM of 2 and 3, whatever you get, then you're going to write it there. How is interesting? Very good. So what's the LCM of 2 and 3? That is 6. So we write the 6 here. Exactly. Very good. Let's come back to calculus. So here we let x to be equal to u raised to the power 6. That is where it's coming from. That is where it's coming from. Even if here is 4, the square root of 4 and 3 will be 12. Here will be power 12. No matter huge, the number is going to be Just write it there. Alright, then after that, what will you do? You take the derivative. So when you take the derivative of x, then you take the derivative of u. So when you differentiate x, you get 1. When you differentiate, know that we are taking integration as respect to x. The operator is x. And this is in terms of what? U. So it becomes implicit. 6u raised to the power 5. Then u ds. So you end up getting ds is equal to 6u raised to the power 5 du. In fact, it's the same as this. When you integrate this, you get ds is equal to 6. You can just do it straight away there and go away. Very good. So now, having this, then we come and do the substitution back. Alright. Oh, you can do the substitution here or here. But I would like to use this one. Okay. Very good. So we are doing the substitution of this and this. So we have integral of 1 over here. Then the ds is so here the s we have here, the s we have here is u raised to the power 6. Hope you can see that. And the ds here can be here. So we can write this as 6u raised to the power 5. Hope you are following. Du over, now watch, half times 6, u raised to the power 3. 1 plus 1/3 of 6, that is 2. Integral of, what is the constant here? 6. Bring it out. What is on top here? 5. What is here? 3. So you can see that this will take away 3 here. So we are going to be left with u squared du. U squared du. And the one on the denominator is going to be u squared plus 1. Please, 1 over u squared is the same as u squared plus 1. Don't worry yourself about it. So we have 6 integral of u squared plus 1 du. Now clearly you can see that the power here is the same as the power here. And if that is so, then we can create and destroy. Here is plus 1, so we can go by plus 1 minus 1. Please, it's not always that if it's in this form, you can do that. No, we do it. We did it in our previous video when we have here to be 1, 1. The reason is just that the power is the same as this. It doesn't matter. It's not always that it's supposed to be 1. If it is 20, 20, you can even use that. So here is 2, 2. So no problem, we can do that. It's a way. 6. U squared plus 1 minus 1 over u squared plus 1 du. So that is going to be equal to u squared plus 1 over u squared plus 1 minus 1 over u squared plus 1 du. This is the same as this. Nothing is changing. So we get 6 bracket integral of 1 du minus integral of 1 over u squared plus 1 du. Very good. So you can see something here. For you integrate this, you get u minus. But watch. If here suppose if here was to be u, just u plus 1, it will be leave u plus 1. But here, because of the square, but this is not anything difficult. This is just tan inverse. So this is tan inverse of u plus c. So that we get the tan inverse of u plus c because the a there is 1. So even if you take 1 over a, it's still 1 over 1, which is 1. So tan inverse of u. But we know that our u is, wow, where is our u? Alright, so if x equals u raised to the power 6, then u will be back. U is equal to, how we can do that? Because we take the 6 root of both sides. Alright, so the 6 root of both sides, we're going to get u because the 6 root of x. So wherever you see u, replace that by that. And you're going to end up getting something beautiful. Alright. Very good. Now, sorry, I left something here. The question is, oh, that's it. That's it. Now, I left something in our previous video right? I did not apply the upper limit and the lower limit. I did not apply it when solving it. But once the understanding is there, you can apply it there. Alright, very good. So go and do that correction. I gave you the integral function. I solved it indeterminate, but not definite, but indeterminate. So you can just do this. It's not anything difficult. Just ignore the C there and do your substitution. Alright, very good. So here, this is indeterminate. This is indeterminate. So I'm saying indeterminate. Infinite. Alright, so that is that. So now we go and do the substitution. So wherever you see u, yeah, you replace that by this. So let's do that. So 6 plus c. So you end up getting 6, or you can write it as the 6 over 30. So that will be the final answer for that. Thank you. And as far as this topic is concerned, we're going to solve a lot of questions. So let's move on to our second question. All right. All right, so we look at our second question. Now, this is involving with two roots, so that should tell you that it's hybrid, sorry, not hybrid, but rather mixture of roots, So we can rewrite this as 1 over or ds over 2x to the power half, the square root minus 3 times the cubic root of x. Alright, so having this, then we can let we can let the inside, and the inside is x. We can let the inside, which is x, to be equal to, and that is equal to the LCM of the 2 and the 3, which is 6. Then we take the derivative. That's going to be ds is equal to 6 u raised to the power 5 ds, sorry, du. After you are done, then you come and do the substitution of this and that. We know that our ds is 6 u to the power 5 du over let's move on. Very good. So we have the ds to be this. Then what is this? Okay. Yes, I'm marking. Alright, so we are doing substitution of this and this. So we have ds here to be that. And then we go into the substitution, but as I said, I'm not doing it here, I'm doing it here. So 2 very good. Now we know that the s we have here is u raised to the power 6. Hope you are watching. Very good. So that is that. Now with this you are going to get u raised to the power 3 minus 3 u raised to the power 2. Very good. Now here, what we have here, we have 6 u raised to the power 5. Here is power 3, power 2. We can factor power 2 out. Then we have 2u minus 3. Hope you can see that. Du. Okay, very good. Now, you can also see that we can bring the 6 out. And this will cancel 2 of this. So you get u raised to the power 3 over 2u minus 3 du. Very good. So, having this, then we now think of quick technique of integration. That is going to help us to integrate what we have. Now, don't forget that the whole question is like, we can't take integral of this. So we do the substitution so that we bring it to something that we are used to it already in our previous videos. So, three techniques that we have learned that is going to help us to do this. You can see clearly that here the numerator, the power is 3, but the denominator, the power is 1, which is improper. Alright? So we solve it by integration of partial fraction decomposition. So we bring out u to the power 3 over 2u minus 3 to deal with it. Alright, very good. And you can see that the dividend is going to be this, and the divisor is 2u minus 3. Okay, very good. So now that we have our divisor and our dividends, then this divide this, what will you get? That is half u squared. And when you multiply this by this, you get u to the power 3. You know how to go by this already, so do that. Very good. And this times this, we're going to get negative 3 over 2u. Alright, very good. Now you subtract and you're going to get 3 over 2u. So here, when you divide 2u by this, what are you going to get? Where are we? Sorry, I think there is a mistake somewhere. This times this, you get it. This times this. Oh, here will be squared. Hope you can see that. So here is squaring. Very good. Now, divide this by this. And you are going to get plus 3 over 4u. When you divide 3 over 2 by 2, you get 3 over 4. Then one of these u will cancel one of this, then that will be u. Then you multiply this by this. Alright. This is not difficult, it's the same as what you have been doing, just that this is involving with fractions. Alright. You did just the long division that you know already. Very good. So this divide, this times this, then we are going to get, alright, then we are going to get 3 over 2. Because when this multiply this, 2 will cancel 2 from the 4. So we get 3 over 2 u squared, exactly what we have here. Then when this times this, we get minus 9 over 4 u. Alright, so that's what we're going to get for the long division. Then we subtract. And when we subtract, here is going to be 0. We are going to get 9 over 4 u. Very good. Then we can still go on to divide this by this because still the power here is 1, the power here is 1. So when we divide 9 over 4 by 2, you are going to get plus 9 over 8. You are going to get 9 by 8. And when you multiply 9 by 8 by 2u, that's going to give you 9 over 4u. Then when you multiply this by this, you get minus 27 over 8. 27 over 8. And when you subtract, you are going to get 27 over 8. So the 27 over 8 here, don't forget that this is a continuation of this. Sorry, this is a continuation of this. So the 27 over 8 here is what we call the divisor. Sorry, it's what we call the remainder. The 27 over 8. And this is the quotient and this is the divisor. So this is just algebra, there is no integration there. So what we have there is improper fraction, which is the improper fraction, which is going to be identical to quotient, which is half u squared plus 3 over 4 u plus 9 over 8. So the quotient plus the remainder, which is 27 over 8, over the divisor, which is 2u minus 3. So for you to integrate this as respect to u, it's the same as integrating all this as respect to u. Hope it's clear. So we integrate 1 over 2 squared plus as respect to u plus this 27 over 8, you can bring it out. Integral of 1 over 2u minus 3 du. So we can integrate that. But don't forget that this 6 is multiplying whatever you are going to get at the end. So just don't forget that. And when you do that, you end up getting you end up getting, okay, so 1 over 6 u to the power 3. Alright, that is when you integrate this, you get u to the power 3 over 3, and 3 multiply these two, that is 6. Alright, so that is what we get there. Now, the reason why I'm pausing here is that for you to integrate this, you have to know that you will take 1 over, alright, 1 over the coefficient of this. So it's going to be 1 over the 2 multiplying this. Alright. So when you multiply, you know it in this way. Let me give it to you. 1 over AU plus 1. This is going to be 1 over 2. So this is going to be 1 over the A, then the. Alright. So that is going to be 1 over 2 times this 27 over 8. Then we take our lead. Alright. And that's exactly what I have done in our next step. Very good. So that's going to be that. But don't forget that we have 6 here. We have 6 here, which is multiplying any result you are going to get for the integration. So if this is the integral, then you multiply the 6 throughout. Alright. So this 6 will multiply throughout. Most students always forget to bring it. Please don't forget that. The 6 we factorize out. I hope you know that part. Alright, the 6 you factorize out, you break it to multiply the whole of this. And now you are done with everything, but just that you have to transform it back to your x's, not to u. So we know that if x is equal to this, then that is equal to that. So whenever you see u here, replace that by this. And I would like you to do that or you go. Alright, so that is that. Let's look at our third example. Alright, so we look at our third example, and you can pause the video and try your hands on it. Very good. So, you know the first principle, don't forget that here is 2 over 3, here is 2 over 5. Alright, so we let x to be, which is the inside of the root, to be equal to u raised to the power. Now, what is the LCM of 3 and 5? That is the one on the denominator. The LCM of 3 and 5, 3 and 5, that is 15. So that is 15. So we end up getting dx to be equal to 15 u raised to the power 14 du. Very good. Very good. So we go and do the substitution. Now, with the substitution, we have here to be 4 multiplying dx, and dx is 15. Let me bring it so that you can see it. 15 u raised to the power 14 du, and the whole of this is over 2 over 3, 2 over 5, and s is u raised to the power 15. Hope you can see that. Very good. So we get integral of, now here you multiply the 4 by the 15, and that's going to give you 60 u. You get 60 u raised to the power 4 du. The whole of this over. Now don't forget that when you multiply 5 by 2 over 3, that's going to give you, u raised to the power 10. Alright, because the 3 will go into 55 times, then multiply 5 by the 2, which is 10, minus u raised to the power 6. So we bring out the 60. Then here will be u raised to the power 14 over the u here. Now don't forget, the least one is power 6. So you can bring that out. And you end up getting u raised to the power 4 minus 1. Alright. Very good. So here 60 integral of. Now, this will cancel something out here. So we get u raised to the power, we get u raised to the power 8 here over u raised to the power 4 minus 1 du. Very good. Now, you see where we have transformed what we have there to be. But it's still not nice. It's still not nice. Let's bring only the integration out. We will bring the 60 after everything, alright? But always don't forget it. Let's bring this one out. What technique is going to help you to solve this? Woo. What technique do you think is going to help us do this? Sure, you are thinking of improper. Yeah, improper can help us to do that. Improper can help us to do that. But there is something also that can help us to do that. That we have to do it. If we don't, we will still need it. We will still need to bring it when we get to somewhere. So, you don't worry. We all know that the first thing you can see here is improper. That is integration by partial fraction decomposition. Let's go for that. After that, we will go to the one that I was saying. So here, the dividend is this, the divisor is this, no problem. So we end up getting this divide by this. Or what should, yeah, this divide by this. And you are going to get u raised to the power 4, this times this, you get u raised to the power 8. Then, this times this, you get, oh, something is wrong somewhere. Or, when you divide this by this, you are going to get u raised to the power 2. Not 4. U raised to the power 2. When this multiplied by this, you get the 8. Then next time this, you get minus u squared. Very good. So you go and subtract. So we get u squared here. And now watch. You can see that you can divide this by this. When you divide this by this, it will be proper, not improper. Here you divide this by this because that will make it improper. But for you to divide u to the power 2 over u to the power 4, this is proper. So you don't need to go and do that. So you leave it. Therefore, the improper fraction is going to be identical to the quotient. It's going to be identical to the quotient, which is u squared, plus the remainder, which is u squared, over the divisor, which is u to the power 4 minus 1. So, having this, then, for us to integrate this, it's the same as integrating this. So we now come back and do that. But don't forget this. And also don't forget the 60. You multiply it throughout after we get everything. Alright, so let me do this here. Hope you can see there. For us to integrate this as respect to you, it's the same as integrating this as respect to you. So we are going to get integral of this is u raised to the power 3, then 1 over 3, plus the integral of u raised to the power 2 over u power 4 minus 1 du. Wow! So we are getting something that we need to think. Let's leave that part. Plus integral of u squared over u to the power 4 minus 1 u. Very good. We need to analyze on the technique to go by this. So you can see that this is proper fraction. Oh, right. But it's a proper fraction. But looking at the denominator, in fact, let me create this part and write only that here for us to investigate. Now, looking at something, look at something. Looking at what we have, even if it's improper, even if it's proper, and we are going to solve by partial fraction decomposition. Wow! But the denominator is it quadratic or what? It's not quadratic, so how are we going to do that? It's something. How are we going to do that? I want you to think something small, think of something small, right? So clearly you are going to see that with this proper fraction is identical to the same as this. And this becomes difference of two squares. This is algebra. So this is going to be identical to u square minus 1 u square plus 1. Hope you can see that. Very good. And with this, we can go and find our partial fraction. So u square over u square minus 1 u square plus 1 is going to be identical to as plus b. Sorry, it's not s but rather u because we are using u here. Au plus b, then here will be u square minus 1 plus cu plus d over u square plus 1. Hope you can see what we have. And the LCM is going to be u square minus 1 u square plus 1. So you multiply au plus b by u square plus 1 plus, then you multiply cu plus d by u square minus 1. I hope you can see that. Very good. So that's going to be identical. So if this is identical to this, then we can equate the numerators. So when you equate the numerators, you get u square to be identical is equal to au plus b u square plus 1 cu plus d u square plus 1. Hope you can see that. Very good. And then with this, we can go on to expand and simplify the right hand side. Alright. So I have that here already. So you're going to get u squared to be cos. Please, you can do that on your own. So you're going to get the simplified form to be this. minus d place. In case you can see, that place is minus d. So that is what you're going to get when you expand and simplify the right hand side. So by comparing, you can see clearly that here you're going to get a plus c to be equal to the coefficient of power 3 here is 0. And when you come to this, let's go for this. You have a minus c here, a minus c. Also, the coefficient of u on the left is 0. Oh, wow. So by adding this, we can get 2a is equal to 0. Therefore, a is equal to 0. And if a is equal to 0, then definitely c2 will be equal to 0. Because when you replace a to be 0 here, c2 will be 0. I hope you are following. Very good. Let's look at one interesting thing. The b. But before we go for b, b is with d. So let's go for d. So now the coefficient is we have negative d, but here is 0. So we have negative d equal to 0. Simply with this one, we don't do any simultaneous equation. So negative d is equal to 0. Therefore, d is equal to 0. Now, if d is equal to 0, then let's see. We have b plus b. B plus b, the coefficient here is b plus d. But then we have u square here. The coefficient here is 1. When you equate it to b plus d, you get 1. But we know that d is 0. Therefore, we get b to be equal to 1. And when b is equal to 1, then gradually we are getting there. Don't forget, a is 0, b is 1, c is 0, d is 0. So we come back here to do the substitution to see what we are going to get. Alright. So please, I hope you are following. Thank you for following. So don't forget, this part is what we are still looking for. So I would like to clean the whole of this. So we know that a is 0, so this place vanish. B is 1, so here is 1. C is 0, D is 0, the whole here, 0. 0 divided by anything, 0. So for us to integrate this as respect to you, the same as integrating this as respect to you. All you are following. Therefore, to integrate this as respect to you, you know that this, we can square this side, alright? So this is just going to be 1 over 2. This is different from 2 squared. Don't forget that. Don't forget that technique. We have already done it. 1 over 2 times a, and the a is 1. So 1 over 2. Then the length of u minus 1, u plus 1. Very good. So that is what you are going to get. Therefore, we have the result for the integration of this to this. So we do the substitution. But if x is equal to u raised to the power 50, then 1 over 50 will be equal to u. So wherever you see u here, put x raised to the power 1 over 50 or 15 root of x. So you do the substitution to this, and you get 1/3 So you end up getting this to be your final results. Thank you, and that give you the rest as trial questions. Oh, I would like to give you the rest as your trial questions. All right, very good. So with the step I used, I nearly forgot. Don't forget that after everything, the one that you factorize out, you go and multiply by it, and that is 16. So you multiply the whole of this by 16. Therefore, you get all of this by 16. So that's going to be your final result. All right. So I would like you to try your hands on this. And wow, Harrison. Very good. That's it. That's the solution. Alright. Here you are to integrate this function, and don't forget that here is involving with one root. This is two roots, two roots. So note that this you can use hybrid substitution. Hybrid substitution. And when you do that, this is what you're going to get. And with this, that is a mixture of what? Roots. Alright. And when you do that, that's going to be your result. If you don't get that, try to get that. With this, the same way, that is going to be your final result. So, thank you, and oh, I forgot to add this. Please, in case I don't know where you have this video, alright. In case you got it from a friend, choose Zenda or whatever, please, I would like you to go to YouTube yourself, alright? In case you want to help us to be bringing more videos, go to YouTube, search Mass Expert. You just type Mass Expert, whether you combine it or you split it. Just search Mass Expert. Check our channel and subscribe it for us, okay? The more you subscribe, the more you help us to bring you more videos. And in case you want to also support, in case you want to support with anything that you can, all right, very good. It doesn't matter the amount, anything that you can, please, you can. Please, the email account is not Echampo Frederick, it's rather Frederick Echampo 88 at gmail.com. Frederick Echampo 88 at gmail.com. You can email me that you want to support us. I'll give you our mobile money account number so that you do that through it, okay? Any amount is not less to support. Thank you, and see you in our next video. In our next video, we are going to talk about the numerical integration, which is the trapezoidal rule, the symptoms rule, and the midpoint rule. In fact, you are going to love it. Thank you, and see you in that video. Until then, know that you are loved.